Welcome to the DIY Honda Garage channel. DTC P2185 refers to an issue where the Engine Coolant Temperature (ECT) Sensor 2's output voltage is higher than the specified value, indicating a fault in the circuit. The ECT Sensor 2 plays a crucial role in providing the powertrain control module (PCM) with accurate engine temperature readings, which is vital for optimizing engine performance and emissions. This sensor is typically located near the engine block, connected to the coolant system, and directly influences how the engine operates. When the voltage signal is too high, it suggests the possibility of a circuit malfunction. The PCM, upon detecting this anomaly, generates the DTC and initiates a set of self-diagnostic tests to identify the root cause. Understanding this code is essential for maintaining the vehicle's engine efficiency and ensuring that any related repair work is performed accurately. DTC P2185 indicates a malfunctioning Engine Coolant Temperature Sensor 2, ECT Sensor 2. The ECT Sensor 2 is responsible for monitoring the temperature of the engine coolant, which is vital for accurate fuel delivery and ignition timing. It is located near the engine assembly, often attached directly to the engine block. When the sensor generates a voltage signal that exceeds the predefined threshold, the powertrain control module, PCM, interprets this as an abnormality. This may lead to less than optimal engine performance or miscalculations in the emissions control system. Consequently, the PCM will store this DTC and may illuminate the check engine light, prompting the need for further diagnostics to confirm and resolve the issue. There are several possible causes for DTC P2185. Firstly, a faulty ECT Sensor 2 may be the root issue. If the sensor itself is damaged or malfunctioning, it will produce incorrect voltage readings. Secondly, an open circuit in the wiring related to the sensor could also result in a high voltage signal being sent to the PCM. This can occur due to damaged wires, poor connections, or corrosion at terminals. Lastly, the issue could reside within the PCM itself, which processes the signals from the ECT Sensor 2. If the other components have been checked and found to be functioning correctly, it may indicate a failure within the PCM that necessitates further inspection or replacement. The symptoms associated with DTC P2185 can manifest in several ways. The most immediate indicator is typically the illumination of the check engine light on the dashboard, alerting the driver to a fault in the engine system. Additionally, since the ECT Sensor 2 is crucial for monitoring engine temperature, a malfunction may lead to the engine overheating, which can be detrimental to other engine components. Furthermore, the vehicle may exhibit poor performance, including reduced acceleration or increased fuel consumption, as the engine management system relies on accurate temperature readings to function optimally. The combination of these symptoms highlights the importance of addressing DTC P2185 promptly to avoid further damage and ensure the vehicle operates efficiently. Begin troubleshooting by turning the vehicle ignition to the on mode without starting the engine. This step activates the vehicle's electrical systems, allowing you to check the ECT Sensor 2's voltage through the Honda Diagnostics System, HDS. It's critical to monitor the HDS reading for the ECT Sensor 2 voltage. If the voltage exceeds 4.92 V, it confirms the presence of a problem consistent with DTC P2185. Note that this inspection provides a preliminary indication of whether the ECT sensor is defective or if there's a fault in associated wiring or components. If the reading is as expected, below 4.92 volts, further investigation into the wiring and PCM must be performed. Documenting all findings at this stage is essential for maintaining a thorough repair history. After completing the initial voltage inspection, the next step involves checking the circuit associated with the ECT sensor 2. Begin this process by ensuring that the ECT sensor 2 connector 2P is disconnected. You'll then inspect for continuity in the wiring path, particularly focusing on TW2, which is related to the sensor signal, and SG6, which represents the ground circuit. It's crucial to examine these wires for any signs of damage, corrosion, or breaks. An open circuit in either of these connections can cause the high voltage reading observed initially. If the resistance checks out as specified, less than 1 ohm in each position, it confirms that the wiring is intact. Should any abnormalities be detected during this inspection, repair or replace the faulty wiring to ensure proper sensor function. After verifying that the ECT sensor and its associated wiring are functioning correctly, the final step is to inspect the powertrain control module, PCM. This component is critical as it interprets the data received from the ECT sensor 2 and manages engine operations accordingly. If the previous steps have indicated that the ECT sensor and wiring are both in excellent condition, it suggests that the PCM may be the source of the issue. Utilize the Honda Diagnostic System HDS to check the PCM for any stored faults or malfunction codes. If the HDS confirms the PCM is not operational as expected, it might necessitate repairs or replacement. A thorough understanding of how the PCM interacts with other components will aid in diagnosing the problem accurately. Always refer to the service manual during this inspection for specific testing procedures and specifications. Once all identified issues have been addressed, perform a final verification to ensure that the repairs have successfully resolved DTC P2185. Begin by using the Honda Diagnostic System HDS to clear any stored fault codes. This step is essential to reset the system before conducting a road test. Following the code clearance, take the vehicle for a test drive to monitor its performance under normal driving conditions. Pay attention to any reoccurrence of the check engine light or changes in engine behavior. Should the DTC not return after this process, it indicates that the earlier repairs were effective. Document your findings and any actions taken, ensuring that the service record remains thorough for future reference. Preventive maintenance is crucial for avoiding issues such as DTC P2185 in the future. Regularly inspect the engine coolant temperature sensor for any signs of wear or damage. Ensure that the connection points are clean and free from corrosion, as dirty or corroded contacts can lead to inaccurate readings or electrical failures. Additionally, it's important to maintain the integrity of the wiring associated with the sensor. Periodic inspection for fraying or breaks can prevent serious malfunctions. Preventive measures can significantly extend the life of the sensor and other related components by ensuring early detection of potential faults. Following the manufacturer's maintenance schedule and advice is essential for keeping the vehicle in optimum running condition. In conclusion, DTC P2185 relates to a high voltage issue within the Engine Coolant Temperature Sensor 2 circuit. Timely addressing of this fault is critical to avoid further engine performance issues. The troubleshooting process involves multiple steps, including voltage checks, circuit inspections, and potential PCM evaluations. Each step provides valuable diagnostic information that leads to the identification and resolution of the problem. Following a thorough diagnostic approach is essential to ensure accuracy and reliability in vehicle repairs. Furthermore, instituting preventive maintenance practices can mitigate the risk of future occurrences of this issue, promoting long-term vehicle health and efficiency. Keeping a detailed service record and adhering to a recommended maintenance schedule are also key steps in preventing similar errors. Please like and subscribe to the channel. See you next time!